Hello, good afternoon, everyone. I am Nikunj Italia, full stack developer from Ghanshyam Digital. We are a software company focused on building clean, scalable, and high quality solutions. We believe that good software should last long, and that start with using strong principle. Let's move on next slide, Shyam sir. Our vision is help developer build maintainable systems by following best principle like solid. Our mission is to create project with best quality code. Now, to explain more about this principle, I like to invite Shilpa Patle. She will give you a quick introduction to Solid. After that, our five groups will each present our solution principle. Thank you. Over to you, Shilpa.
Next, next, next. Let let's begin with understanding solid principle. Let's begin with understanding solid principles which help us write better and more reliable code. Solid is a set of five principles in object-oriented programming that help developers write clear, understandable, and maintainable code. This principle makes software easier to scale, test, and modify over time. Solid is actually set of five design principles and each letter stands for one principle. S for single responsibility principle, O for open source principle, L for Liskov substitution principle, D for dependency inversion principle. Now Dhruvi will explain SRP which is first principle of solid. Dhruvi, you can start.
Now let's understand SRP. What is SRP and why SRP? The single responsibility principle in a simple way. SRP means that a class or function should have only one job or responsibility. Benefits of SRP उसका benefits क्या है कि this make the code cleaner, easier to understand and easier to update in the future. Next slide. Let's take an example without SRP and with SRP. First, take an example without SRP. Suppose we create a class called user. This user class is doing three jobs like create user, send email, and log error. Then it's doing too much that breaks SRP. इसमें क्या होगा कि कुछ कुछ वेरिएबल्स हो गए जो एक दूसरे में यूज कर रहे होंगे, सेड वेरिएबल्स हो गए, तो एक क्लास में कुछ चेंज करेंगे, एक फंक्शन में चेंज करेंगे, तो वो डिपेंडेंसी के हिसाब से वो दूसरे में भी चेंज करना पड़ेगा, ऐसा होगा। तो उसका बेटर वे है हम एसआरपी अप्लाई करें। नेक्स्ट स्लाइड। तो उसका बेटर वे है कि वी कैन स्प्लिट दिस into three separate classes. User service classes only create the user, email service classes only send email, logger classes print log the error. Now each class has one responsibility and it become easier to test, reuse and maintain. Now Sohil will explain how to apply SRP. Sohil, you can start.
Yeah, hello guys. Am I audible? Hello.
Yes.
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 Yeah, I am going to explain today how to apply SRP in our day-to-day code practices and what are the benefits of that and what are the disadvantages that we are going to face in the code practices. So we will discuss first of all key points how to apply SRP. Uh, as we explained already that every class contains set of instructions that are going to be written by a developer that we are going to check out. First of all, we need to check that all responsibilities of a class, that what exactly is the class going to perform, each task and each method that is going to write. Split, if it handles more than one, means that if it is handling more than one task at a time, we need to split in different classes for better code execution and code readability. And it is helpful in large applications to read code easily. Use dependency injection for shared functionality. For this, we are going to discuss a small example. As you can see on the screen, there is an interface called logger. Here, two small pieces of classes has been created. One class is holding a logic for inserting a log message, and another, the report generator class, has been holding the logic for generating a report. But the problem is, here we want in generate report, we want to generate report also, and we also want to insert a log message. So we are going to inject the logger class in our constructor in order to use the shared dependency injection uh, by creating an instance of the logger, so that we can create and easily handle the function generate report for handling the report logic, and then we will insert a log using its instance. Next, please. Yeah, common pitfalls means how the developers are getting confused with with the points of the SRP that that are we going to discuss in this. Oversplitting too many tiny classes means you create 10 tiny classes, each with one line of the logic, make it harder to understand. Means SRP stands for that every class should contains only the logic that is going to be performed one single task at a time. It doesn't means that you create one single class for each one line logic. That is not going to prove anything. Confusing SRP with one method per class means to consider that only one method is going to be there in one class. It is not going to follow the SRP principle, as the method should only be different in another class unless and until it is ignoring the cohesion principle. Means related responsibilities can stay together. Uh, like let's take an example of a user object in which we are going to create some three different methods, like authenticate user, sign up user, and forget password. So here we are not going to create a forget password method in one class, sign up in another class, and authenticate user in third class. We will only create one user class in which three methods are going to be created. One is for sign up, one is for forget password, and is for authenticate. Means one related responsibility can stay together in one class. It does not bother anything. Next, please. SRP key takeaways and best practices we need to follow. SRP is not just for classes, it can also apply to methods, modules, and services. About services, we already have discussed about it with the user module. If we talk about the methods, there is an example for the process order method in which we have created three different utilities: save to database, send email confirmation, and generate invoice. So it is wrong according to the SRP principle. We are going to create one method as the save to database method contains different logic, different module. Email confirmation contains different logic, and obviously it is from different module. And same for generate invoice also. So we are going to create three different classes and create three different methods in them, and we will inject them in our constructor, and we are going to use that in our process order method. Following SRP leads to better separation of concerns. Means that if we are creating separate methods in separate classes, it is easy to understand, and the code is ready to use whenever you want to execute or reuse it, as it's only used to call, and you can good to go. Encourages writing unit testable components. Means it boosts the confidence to write the code, as it you just need to write a piece of code in a smaller, as you don't need to create multiple methods, as it is already has been declared. works well with dependency injection and clean architecture. Clean architecture, as we discussed it right now, that it's ready to read and easy to access when we are when we are working on a great big size team and multiple developers. It is good to go for processing the SRP principle. The conclusion is by applying SRP, we can reduce bugs, improve teamworks, and support company goal to deliver high quality and scalable applications. Thanks. Now we are going to discuss the another module which is going to be present by the group 2, and they will be continuing for further operations. Thanks.
Thank you, Sohil. Hello, everyone. Let's discuss about the open close principle. The open close principle states that software entities, classes, module and function. It means अगर हम कोई भी क्लास या मॉड्यूल बनाना चाहें तो उसको मॉडिफाई नहीं कर सकते, हम उसको एक्सटेंड करके यूज कर सकते हैं, न्यू फीचर्स ऐड कर सकते हैं। और इससे बेनिफिट्स होते हैं कि जैसे हमें ऑलरेडी जो हमारा कोड है उसको टेस्ट नहीं कर सकते, मतलब हम उसमें न्यू फंक्शन ऐड करके यूज कर सकते हैं। नेक्स्ट, नेक्स्ट अंडरस्टैंडिंग द ओपन क्लोज प्रिंसिपल। ओपन कोड एक्सटेंशन इट मीन्स कि जैसे हम कोई भी क्लासेस बनाते हैं या मॉड्यूल बनाते हैं तो हमें उसमें चेंजेस मतलब मॉडिफिकेशन के बिना हम उसमें फीचर्स ऐड करके यूज कर सकते हैं। जिससे हमारा जो एग्जिस्टिंग कोड है उसमें कोई भी बग्स या फिर टेस्ट करने की अगेन एंड अगेन नीड नहीं होती है। इसलिए क्लोज फॉर मॉडिफिकेशन, क्लोज फॉर मॉडिफिकेशन इट मीन्स कि हम कोई भी कोड टेस्ट या फिर डिप्लॉय कर देते हैं तो उसको हम चेंजेस नहीं कर सकते उसके बाद। प्रिवेंटिंग रिपल इफेक्ट, रिपल इफेक्ट मीन्स जैसे कि हम किसी भी चीज में थोड़ी भी चेंजेस करते हैं तो वो पूरे को पूरे में चेंजेस कर देता है, इसलिए उसको मिनिमाइज करने के लिए रिपल इफेक्ट। नेक्स्ट, वाई ओसीपी मेथड की बेनिफिट इम्प्रूवमेंटेबिलिटी। जैसे हम इसमें रिड्यूस करता है कि जो कोड ब्रेक होते हैं या फिर इसमें कोई भी वर्क्स आते हैं उसको रिड्यूस करता है। इंक्रीज टेस्टेबिलिटी, हमें बार बार कोड रिटर्न करके फिर उसको टेस्ट करने की जरूरत नहीं है, हम जो एक्सटेंड करते हैं उसको ही टेस्ट करना होता है। फिर इनहेंस एक्टिविटी, जैसे हम उसमें एक्सटेंड कर सकते हैं जिससे जो डेवलपमेंट लाइफ साइकिल होता है वो इंक्रीज होता है। और रिड्यूस कबलिंग, जैसे एक कंपोनेंट दूसरे पे डिपेंड नहीं होता है, वो मतलब जो डिप्लॉय हो चुका है उसको हम बार बार टेस्ट नहीं करेंगे या फिर उसमें कोई भी बग्स या फिर ऐसा कुछ नहीं होगा। नेक्स्ट टॉपिक, एक्सप्लेन बाय डिंपल खत्री। हेलो एवरीवन, हेलो।
Uh, okay, so
Okay, so let me take this further. So here's a example of OCP violation. Here's we can check that here's a violation of the OCP. We have defined a class rectangle where we are passing the width and height. The same with another we have another class circle where we are passing the radius, and we have a function to calculate the area of the circle and rectangle, the different shapes. We'll be passing the shape and what type of shape and all that. So at the last we are just returning the based on the formula we are returning the area. So for say rectangle it would be shape width into height. Same it will for circle it will be pi r square. So we are just returning that, and here we can check that in the function calculate total area we are passing the total area of the all shapes, and last we are just calling the rectangle and circle classes. So in this case if there's a in the future if there's a change like we have to pass the we have to implement the same for a triangle as well. So it will cause an error like we have to change the previous code. We have to change this function and all that. So it will violate the OCP, and it's not a good coding practice. So we will see the solution in our next slide. It will be presented by Dimple Khatri.
हेलो एवरीवन, यहाँ पे हमने ओसीपी कंसेप्ट का यूज करके एक सिंपल एग्जांपल क्रिएट किया है जिसमें हमने एक सेफ क्लास डिफाइन किया है जिसमें एरिया करके कंस्ट्रक्टर है और उसके नीचे हमने दो क्लास बनाए हैं, रेक्टेंगल और सर्कल। और इसमें हमने रेक्टेंगल की विड्थ और हाइट और रेडियस सेट किया है और सर्कल में भी सेम वैसे ही। और नीचे एक कैलकुलेट टोटल एरिया करके फंक्शन बनाया है जिसमें हम शेप को एक्सटेंड करेंगे और उसका टोटल एरिया काउंट करेंगे और वहां से थर्ड एक शेप में उसको पास करेंगे रेक्टेंगल और सर्कल का रेडियस, हाइट, विड्थ वो सब। और लास्ट में हमने उसका लॉग करवाया। और इसमें हमें जो रेक्टेंगल क्लास ऐड करना है इसकी विड्थ, हाइट और रेडियस का कैलकुलेशन करना है, तो हम यहाँ पे इजीली कर सकते हैं। हमको हमारा कोड चेंज करना नहीं पड़ेगा, मॉडिफिकेशन इसमें नहीं होगा और हम सिंपल एक क्लास ट्रेंगल बना के उसका कैलकुलेशन ऐड करके हम ऐड उसका रेडियस फाइंड कर सकते हैं इजीली। नेक्स्ट आपको दूसरा कंटिन्यू करेंगे।
Okay, so here we have the strategies to for the OCP compliance, like what are the methods and how can we compliance with the OCP. So here, for the first one is the polymorphism. We will be defining an interface, a common interface or abstract class, and new behaviors can be added by creating the new class and without modifying the existing code and existing classes. So polymorphism is one of the best solutions for the OCP compliance. Next, we have the strategy pattern. We can encapsulate a family of algorithms like which are interchangeable. So new algorithms can be implemented easily and leaving the older code and existing classes unchanged. So there won't be any change in the previous classes, but we can define new algorithm, family of algorithms, which can be interchangeable. So yeah, this is another solution for strategies of OCP compliance. And then next we have template method pattern, which defines the skeleton of an algorithm from a base class and differing the steps from a subclass. So a new variation of the algorithm can be overridden by the steps in the new subclass. So this is one of the uh, not mostly used, but yeah, this is also a very good method of strategy for complying with the OCP. Then next we have decorator setup, which allows the behavior to be added in the individual object dynamically without any without affecting the other objects in the same class. So we'll be adding the new objects without disturbing the existing one, and new functionalities can be wrapped around existing objects. So yeah, this is one of the another pattern to cope up with the OCP compliance. And then next we have dependency injection. Instead of class initializing, instancing the dependency directly. So in this case, we will be instancing the dependencies without directly instancing the classes. So This will easily swap the implementation of dependency without modifying the client class. We don't have to modify the client class, and this will follow the OCP principle, open close principle, and it would be a great way to cope up with the OCP compliance. Okay, so we're moving on to next slide. Okay, so here's the conclusion for the OCP principle. The essence of OCP. The OCP principle ensures that the entities are open for extension but closed for modification. Like we can extend the classes or like extend the functions and all that, but we won't be modifying the existing code and all that. So it will reduce the risk of um, just a second. So it will reduce the risk of new bugs and a new we can add easily new feature, add the new features easily without creating the bugs in the previous code. Okay, so and the key benefits we have discussed that it is highly maintainable, scalable, reusable code bases, and it minimizes the impact of changes and the birth to new bugs in our existing code. So it will be a faster development process. It will create a faster development process for us. These are the key benefits. And then we have strategic application. Achieving OCP compliance involves like a pattern. We can be use concepts like polymorphism, strategy, template method, decorator, and dependency injection as we discussed earlier. And this strategy can help us to cope up with the OCP compliance. And then building for the future. The OCP can be helpful for the developers that will stand a test of time, the testing time, and it will be easy for the business to move on further and add new features without disturbing the existing features. So yeah, that's all from my side for the OCP principle. Now we will be moving on to the next principle, that is L. Team L will be presenting the L principle. Thank you.
Uh, Thank you, Rudra. Now start with another principle, Liskov substitution principle. That means if S is a subtype of T, then object of type T may be replaced with object of type S without altering any desirable properties of the program. That means जो चाइल्ड क्लास होता है वो पेरेंट क्लास को रिप्लेस कर सकता है बिना कोई भी मेजर चेंज किए इन पेरेंट क्लास. In simpler terms, a child class should be substitutable in place of its parent class without breaking the apps. That means जो child class है वो अपने पेरेंट की कोई भी प्रॉपर्टीज को एक्सटेंड कर सकता है बिना पेरेंट क्लास के चेंजेस के, जिसकी वजह से जो हमारा एप्लीकेशन का फ्लो है वो ब्रेक नहीं होगा और हमारा एप्लीकेशन स्मूथ चलेगा. नाउ सचिन गिव एग्जांपल टू रियल वर्ल्ड एनालॉग. प्लीज स्टार्ट सचिन.
Okay, so hello everyone, my name is Sachin. I am explaining you about the real world analogy of LSP. So we can take two examples like there is a electric car and a petrol car. Petrol car we usually see which runs on petrol and the outer part of it, the structure of car. Okay, it is the same as an electric car. Electric car also do the same work like the petrol car, which is a medium of transportation. So we can change the functionalities of electric cars or any other cars which we want to update. But okay, you don't need to relearn how to drive a car. Okay, they perform the same functionality. In relevance of LSP principle, we can see there is a React Native button component which is majorly used. Uh, Here we can see that there is a loading button, which is a generic button component we can build in using LSP. Okay, next slide. Okay, the problem without LSP. Let's see this. Basically, the React Native paper library provides a button component uh, can- to provide a functionality to submit or press the button. Okay, there are two properties basically on press and mode, which are used in a basic button in React Native. But we can also make a loading state button which can be used to scale as we wanted. Like imagine without a LSP, we cannot extend the basic button which was provided by React Native paper. Okay, thank you.
Hey everyone, so myself is Parth Singh. Okay, so basically the fundamental of LSP is we take some other class component and take it back. Like in here we have our loading button, but in loading button we have inherited the button from a React Native paper. So basically it's just like a design pattern. As you see in all the website, the buttons look same across the application. Wait a minute. Okay, sorry. Huh. Hello. Am I audible now?
Yes.
Yes, audible.
Yes.
Yes.
Ah. So basically, we have one loading button. It is our custom component. In here, we have inherent the button which is coming from a React Native paper. So what we are doing, we are just adding this particular button in all our application so that the design looks same. Now the next slide, please. Okay, so here is the flow. There is a base component. Okay, then it is our custom component, that is our loading button. Then there is a props and our dynamic logic. So base component is the button from React Native paper as a serve as a base defining the fundamental interface and expected behavior. Wrapper and extension is the loading button components wrapped and extend the base, ensure its interface remain consistent with the parent. And consistent props means if we want a button to be disabled or if we want to show the button as a loading button, at that time we can pass with this prop as well. And dynamic logic is whenever the form submits, at that time what event we have to do, at that time we can use our dynamic logics. Okay, so next slide. So sir, you can continue now.
Thank you. Now in this we are going to discuss about benefits of LSP, or why we should use, and what if we don't use, then what kind of problem we can face here. So advantages, we can use the child classes anywhere without affecting the other parent class, and it will not break the flow. It will be easy for us to maintain, easier to update and fix bugs. Uh, it also help us to build a solid foundation for a large project. And what if you don't use LSP? So if the child class changes behavior, your app behave incorrectly. It will be hard to debug and code become harder to manage. And code duplication problem we can also face. Next slide, please. So the summary of the LSP, if a program works with a parent class, it should also work without an error or unexpected behavior. Uh, it makes sure that your program works well even when using a different classes and make future changes easier. In the end, LSP helps you to write better and safer code. So that was from our side. Next group team.
Thank you for giving me this opportunity. I am Yug and I am presenting today along with Dhruvang, Raghav and Pratham. Our topic is one of the most important software design principle for the SOLID group, the I in SOLID. which stands for Interface Segregation Principle, or we can call it ISP. This principle helps developer to write better and cleaner code by keeping interface focused and avoiding all unnecessary features. Today, I will be giving a simple overview of principles and why it is useful. Moving on to next slide. So you may ask, what is exactly interface segregation? In simple words, the principle says don't force a class to implement method it doesn't need. Let me take an example to explain this. Imagine giving a heavy toolbox to someone full of tools they will never use. Instead of that, we can separate the tools that into different categories so that we can use it easily and no one will waste time dealing with unnecessary tools. This this is exactly what we aim for in the code. Break large code and general code into interface and smaller interfaces. This keeps code simple and easy and focused to manage. Moving on to next slide. Now let's talk about why principle matters in real life project. First of all, it helps keep our clean code clean and simple. By reducing unnecessary code, everything becomes readable and easier to understand. Second, it avoids confusion. When interface has extra methods, developers might feel they have implemented or used them, even when they don't need. Third one, it makes testing and updating much easier. In interface, we are smaller and change are less risky, and we can easily catch the bugs. And fourth one, finally, it keeps our code modular and maintainable, meaning it is easier to build, grow, or adapt software as requirement changes. Now I would like to call Raghav for giving ISP example in more detailed way.
Okay, thank you, Yuk. Next slide, please. Yeah, so here we will see some realistic scenario that we can have that in which we can use the ISP principle. Uh, yeah, so let's suppose that we have an e-commerce website and there are several methods for payments in that. For example, we have three payment methods: credit card, UPI payments, and cash on delivery. Now, if we try to put all these three methods into one interface. For example, we can see in the first code that we have made an interface named payment processor. Here we have all the four methods in a single interface only. So if we try to use all of it, if we try to implement this interface in a class, for example, we have a class of cash on delivery. Now cash on delivery will not use all the four methods. For example, cash on delivery doesn't require validate card details, it doesn't require validate UPI. But since we have implemented it in an interface, we are supposed to use all of the methods in some way. So we will throw errors in the validate card details and validate UPI as you can see in the code. And we will only use the process payment method and send invoice. Now this will create unnecessary weight in the classes since we are supposed to write some functions which are not even necessary. This will uh, this will create bad codes in the code base. Next slide, please. Yeah, so here, as we can see that we have applied the interface segregation principle. Now here, as you can see that all the methods that we have seen in the previous code are separated in different interfaces. For example, interface of payment, interface of card payment, interface of UPI payment, and interface of invoice sender. Now this will increase the readability. This will increase the utilization of each interface properly, efficiently. That we can see in the next slide. Next slide, please. Yeah, so here as we can see that we have three types of payments: Stripe payment, which will use credit cards, then next is cash on delivery, and another one is UPI payment. Now in the Stripe payment, we only require process payment, validate card details, and send invoice. Only three methods are useful. So we will import all of these three methods from its own interfaces. Now we here using ISP principle, we reduce the code weight. We are not now importing unnecessary methods. And that you can see in cash on delivery code also. As you can see, the cash on delivery code is very small now, and it is not having any unnecessary weight of codes. Next slide, please. So another example that we can think of is authorization principle, where uh, there are several methods for sign in and login. Now, first, one of the methods can be using email password. One of the methods could be using login with email, login with Google, or login with Facebook. Now, if we implement login with Facebook or login with Google, then we do not require a reset password or any sort of reset password implementation. And in admin, in email and password implementation, we do not require any OAuth token. So that we can see in the next slide. Next slide, please. So here we can see that in the first code, we have implemented all the necessary methods in one interface only. For example, login, for example, reset password, then two-factor authentication, and generate OAuth token. All of them are all of them are in one interface only. Now, if we try to implement this interface in OAuth class, then we can see that we only require login, then OAuth token, and get roles method. We only require these three methods only. But since we have implemented an interface which includes all of the methods, we need to throw errors for reset password and enable two-factor authentication, since we do not require both of them here. So again, as we can see that this created unnecessary load in the code. Next slide, please. Yeah, so here as we can see that we have separated all the methods into different interfaces. Each of them are having each of them are doing just one thing, and this can further be readable also. Next slide, please. Yeah, so here as we can see that we have utilized the previous interfaces where we have separated all the methods. Here we can only import those methods, those interfaces only which are required. For example, OAuth now requires only auth token and role provider. We do not require the other two functions that we have seen in the previous code. This makes our code efficient, more readable, and more understandable. Next slide, please. Yeah, so this is also an example of implementation of that interface where we have separated all the methods. So in this way, we can see that it is the ISP principle makes code really readable, efficient to use, and reduces the unnecessary lines of codes. Now, handing over next further presentation to Pratham. Thank you.
Hello everyone, my name is Pradham. Am I audible?
Yes.
So here we have a customer login API where if we go to the line by line, first we are taking user mobile number and checking it into the database, and then we are checking that it is valid or not. If it is not valid, then we are sending error message and other necessary validations. After checking all the necessary validations, we will generate an OTP and save it into the database. But if we see the code, it is very messy. To make it more readable and understandable, we can create more further methods, and we can use it here, and also we can use it in many places where we need it. Next slide. Here we have created first method, get user by mobile number, where we will check mobile number of the user and other necessary validations. We have created also a method for that. Next slide. And also here is a error message class where we can show user validations for user error messages and generate OTP. We also created a method for generate OTP, and also to update the database, we also created update user data method. Next slide. Here we have implemented some methods like get user by mobile number then checking it and other necessary validations. And then after that, we are generating OTP and saving it in the database. Here we have here we have made the code very clean and readable. Here we can also find the errors and make the code very readable. Next slide. Here is another API where we have used the get user by mobile number, user validations, and throwing the validations and generating OTP and saving it into the database, making the code reusable. Next slide. Here, Ruang Bhai will continue.
Okay, thank you, Pratham. So, if we say in a nutshell that what is interface segregation, that means अगर हमने एक साथ multiple methods implement किए हुए हैं, अगर वो एक दूसरे में incorporate हो रहा है, और मान लो कि हमें एक ऐसी situation create होती है जहाँ पे some of that methods are not usable that at all. So हम क्या कर सकते हैं कि एक अलग interface बना के उसको incorporate कर सकते हैं two different interface में, and of course we can implement multiple interfaces within a single class, right? So that will be more convenient, and it will make the code base clear, as particular interface will focus only on particular movement, right? And other thing is it will be convenient for other team members as well, as they will need to use particular interface, and they can use it without any hesitation, as it is focusing only a particular situation, right? And scalable architecture as well. If we want to add more methods or need to make any changes, we can do it easily, as we have separate interfaces for them, right? Okay, so I guess it is clear now. We can move toward the next topic, which is dependency in inversion.
Hello everyone. This dependency is most used in development. यहाँ पे हमारे पास दो वर्ड है, डिपेंडेंसी इन्वर्जन. डिपेंडेंसी क्या है? अगर हम अपने क्लास में कोई और क्लास का ऑब्जेक्ट यूज कर रहे हैं तो हमारी क्लास उस ऑब्जेक्ट पे डिपेंड है. और डिपेंडेंसी इन्वर्जन क्या है कि हाई लेवल मॉड्यूल्स शुड नॉट इंपोर्ट एनीथिंग फ्रॉम लो लेवल डिपेंड. तो यहाँ पे क्या है कि जो हाई लेवल मॉड्यूल्स है वो लो लेवल पर डिपेंड नहीं कर सकते हैं. नेक्स्ट स्लाइड. What is dependency injection? Dependency injection is a software design pattern where objects receive their dependency from external source. There are three types of injections. First of constructor injection. This dependency injection patterns where dependency are provided to an object through its constructor when the object is created. It's one of the most common and recommended form of dependency injection. Second one is setter injection. Setter injection is dependency pattern where dependency are provided to an object through setter method after the object has been constructed. Third one is interface injection. Interface injection is a dependency injection pattern where dependency are provided through a well-defined interface that the depend class must implement it. Next slide. Baksa, you can continue.
Yeah. Hello everyone, myself Bhavisha Amipra, and now I'll explain the benefit of DIP. First is loose coupling. This simply means that our main part of the project, high level code, don't directly depend on small part, low level code. Because of this, it's easy to make changes in one part without breaking the whole system. So everything becomes more flexible and easy to handle. Second is testability. When we use abstractions like interface, it becomes easy to test our code. We can use fake versions like mock objects to test one part at a time without depending on the real implementation. And third is a maintainability. Since part of the code are separate, it's easy to update or fix something without affecting the whole project. This make maintaining the code simple and faster. Fourth is scalability. If we want to add a new features or make the system bigger, we don't need to touch the old code. We can just plug in the new features. This makes the system easy to grow without much effort. So overall, DIP makes our code clean, easy to test, easy to change, and easy to grow. That's why it's very useful in real projects. Now Faizan Sheikh will explain the example of DIP in a simple way. Faizan, you can start.
Yeah. Hi guys. My name is Vedansi. Let's talk about what's problem without DIP. We are write a code using a DIP. We write a loosely coupled, testable, and extendable our application. Uh, the real world problem without DIP. Here, this is the example where create the class. Yeah, हम्म, जैसे हमने एक क्लास क्रिएट किया है ईमेल सेंडर। वो एक लो लेवल क्लास है। वैसे ही हमने नोटिफिकेशन का जो क्लास क्रिएट किया है वो हाई लेवल क्लास है। हमने डायरेक्टली जो ईमेल सेंडर क्लास है उसे हमने डायरेक्टली नोटिफिकेशन में यूज कर ली, नोटिफिकेशन के क्लास में यूज किया है। This is the tightly coupled. The problem is the coupling. Notification is bound to email sender, too difficult to test and not extendable. Next, uh, solution using a DIP. Uh, हम जब DIP का यूज करते हैं तब हम हमें एक इंटरफेस बनाना रहता है जो हम जो लो लेवल मॉड्यूल होते हैं उसमें यूज कर सकते हैं, ईमेल सेंडर और एसएमएस सेंडर। और उसका हम हाई लेवल क्लास में यूज कर सकते हैं यूजिंग द इंटरफेस। जो लो लेवल जो हाई लेवल नोटिफिकेशन क्लास है उसमें हम इंटरफेस का यूज करके वो मेथड को हम एक्सेस कर सकते हैं। the code easy to extend हो जाता है और बेटर टेस्टेबिलिटी एंड मेंटेनिटी। नेक्स्ट, conclusion and key takeaways. The dependency invention principle is constant of the flexible software architecture. By depending on the abstraction instead of concrete implementation, your code becomes a cleaner, more testable, and easier to maintain. Uh, some key takeaways. The DIP separate high-level policy for low-level details. The dependency injection is a practical technique to the implement DIP. The imbalance to interface extraction to design scalable system. Next, thank you for your attention. I am happy to answer any question you may have.
No, we are good to go.
Okay. Thank you all the teams for your hard work and efforts. And just to summarize, Solid is set for 5 coding principles that helps us to write better software. It's make our code cleaner, easier to understand, and simple to maintain and scale over time. It's all about writing code that's not just working today, but easy to change
सही था
tomorrow.
कि नहीं था? समझ आया कुछ?
And just a quick overview. S.O.L.I.D stand for first one is as single responsibility principle. Every class and a function should have only have one job. For example, a class that handle only invoice shouldn't also send emails. Keep responsibility separate. Second one is open close principle. Software should be open for extension but closed for modification. Uh, Example, instead of changing existing payment or code for every new method like UPI, card, wallet, we add a new ones without touching the old code. Third one is Liskov substitution principle. A subclass should be replaceable for their base class without breaking the code. Example, if you have a bird class and a plugin subclass, you don't assume every bird can fly. Fourth one is interface segregation principle. Don't force a class to depend on method it doesn't use. For example, think of a video player, a basic video player that only play videos shouldn't be forced to implement feature like recording or the streaming. Uh, Fifth one is dependency intervision principle. Depend on abstraction, not constant class. For example, your app shouldn't depend on the general database service interface, not directly on MongoDB or SQL. Now let's have a quick short Q&A session. So feel free to ask any question to the teams for me and share your thought about their presentation. Anyone, if you have a question, please ask to the teams for me. Okay.
Nikunj,
Uh,
I have one question. Can you explain this Liskov substitute principle in a brief, in 2 to 3 lines? Timel, can you please explain, like in 2 to 3 sentences, what is Liskov substitution principle? Like if you want to explain in simple terms, what it can be. Am I audible? Anyone?
Team L, please respond.
Yeah.
Team
Team L members, please respond.
Liskov substitution principle. Harshal, Padbhai.
Hello, sorry. What you are saying, wrong?
Yes, I was asking that. Can you please explain 2 to 3 sentences, like in a brief, like what's this Liskov substitution principle? Why exactly we should use this?
It's just a simple term. Like whatever we apply into our in a simple term, like let's suppose we are using React Native, right?
Yeah.
Okay. In a simple term, if you see any of the website, the UI buttons look like a same, right? There is no difference. But what our juniors are doing is they create almost in every screen, they create some different UI and showcase to the particular screen. Matter the UI will be consistent throughout our application. Yes, that that's just a simple example.
Okay, but it is saying that if we don't use the parent, the child should remain unchanged or something.
Yes, correct.
So we are using the same component in every single screen, right? To make it consistent.
Yes,
So
correct.
how will it make it different? Like if
Yes.
we just remove the main component, that
What
children will.
do you mean
Okay,
about
so
removing the component means?
wait. So in this, the child is that button, right?
Can you just share your screen and showcase to me?
Okay, let me share my screen. Can I share my screen? Okay. Yeah, that's good. Thank you.
Thank you.